Hey there! In this video, we are going to talk about the useIdle composable from the VueUse library. VueUse is a collection of utility functions you can use in your Vue.js projects. It exports a useIdle composable, which can detect when the user becomes idle on the page. It uses a timer, and every time the user interacts with the page, the timer resets. This is what we will implement today with XState because I think timers are a really great use case for XState. Let's see how we can do this. This is the useIdle composable. It takes the timeout parameter to consider how much the user can stop interacting with the page before being considered inactive. Then it sets a bunch of event listeners if window is defined, meaning if we are not doing server-side rendering, then we set a bunch of listeners. This events list comes from the top of the file. The events the function listens are mouse move, mouse down, resize, key down, touch start, and wheel. So these are the events listened to by the function. Please note that the passive parameter is passed to the add event listener function from JavaScript DOM API. This is to improve performances, and consider that this callback here on events is not the most important one. So on event, the callback passed. This is a function that will be run in the browser. It sets the last active value. So last active will hold when the user was last interacting with the page. And it calls the reset function, which passes idle to false, sets a timer with the timeout duration, after which the idle value is now set to true. And when the reset function is called, it resets the previous timer if there was one already set. This is how it works, and please note that imperatively when the useIdle composable first runs, the reset function is called to directly configure this timer, this one, when the function is first called. So we will reimplement all of this with XState, and there is two other things to mention. The user can switch between tabs in the browser, and you can listen to this event with the visibility change. So this event is called when the visibility of the tab changes, and document hidden equals true if the tab is not the one currently selected. So the useIdle composable runs the on event callback when this event happens, when the document becomes visible again. So not document hidden equals when document is visible. The other thing to mention is that useIdle throttles the events. The function, this one and the reset, this can be really heavy to execute on the browser if you receive a lot of events. So this create filter wrapper function takes an event filter which is defined there. Throttle filter is here to throttle by 50 milliseconds all these events received. What it means is that each time you receive an event, the functions will be called, the callback, it will be called, but for 50 milliseconds, you won't be able to call this callback again. So the code will just stop hearing from events during 50 milliseconds. We will reimplement this with XState because throttling and debouncing are patterns really easy to implement with XState. So this is what I can say about the useIdle function. Now let's see how we can reimplement this with XState. So let's create the state machine. First, we will call it user activity machine. I call the setup function from XState. We will use it to type the machine and provide default implementation for actions, services, etc. And okay, so the first thing is that by default we will consider the user as active. So first state will be active. Oops, initial active. And the other state will be inactive. When the user enters the active state, we want to start a timer. We will use the after keyword, which creates a delay transition, and we'll say after 5 seconds we will target the inactive state. Now we want to listen to an event, which will be, okay, the user interacts with the page. And this event, we will call it activity. So I go to the setup, here types. Types allows you to define the types of the machine. Here I will define an activity event. This activity event will be triggered every time the user interacts with the machine. So here in the active state, I listen to the activity events, and every time the user interacts with the machine, we want to consider the user as still active. So we want to reset the timer every time the user interacts with the machine. It means the user needs to be considered active for, again, 5 seconds in this case. We will take 5 seconds for now because it's great for the example, but in a real world scenario for your application, we would like to use something like 1 minute. This is a default value for useIdle, 1 minute. So after these activity events, we want to target the active state again, but because we are in the active state, this will do nothing. What we want to do there is to use the reenter true property. Reenter means I'm in a state. I want to self-transition to this state, but I want to reset the timer that is started by this state. This reenter property will make the transition as if we were exiting the state and re-entering it. Please note that this reenter keyword will also re-execute invoked actors or call exit actions and enter actions again. You will really exit the state and re-enter it. So like that, we recreate the timer after 5 seconds. We also want to listen to the activity event when we are inactive. When we are inactive and receive an interaction event, we want to target the active state. Okay, great. Now we have the states and the transitions. But if you remember, in the useIdle code, there is this last active variable. This one is set to the current timestamp every time the user interacts with the machine. We need to do that in the state machine too. So we'll create a property in the context called last active. It will be a number. This is becoming red because we need now to provide a context. Previously, we were not defining any type for the context, but now it's required. So context, and I will assign a function to the context property because I want it to be dynamic. Last active will be date dot no, I have a utility function for this. It will be timestamp by default. So when the state machine is executed, this context function will be executed, and the value for the timestamp will be the one of the time it's executed. So if I was creating this context, last active, and var timestamp. This function will be executed with the model, the JavaScript model. So this is not what I want, because you can import a file, execute and pass the model, but you don't immediately call and execute the state machine. So we want instead to use a function to make this dynamic. Great. And now every time we receive this active event, we want to assign the new timestamp to the last active property. So what you can do is define an action. We will call it assign current timestamp to context. There I use the assign action from XState, and last active will be timestamp. Okay, and now we can call this action var. You can see that there is auto-completion thanks to the setup function from XState 5. I really love this feature. Okay, and we are good with this. Before testing in the browser if it really works, we need to create a callback actor that will listen to the DOM events. So to create this DOM listener logic, I will use a from callback function from XState. There I provide a function which takes the sendBack function as parameter. SendBack is to send an event from the logic to the parent state machine that invokes this logic. Here I will loop over the events of default events, and I will create a callback handle window event which will call sendBack with activity events. I take that window.add event listener events the callback and passive equals true. Okay, the benefit of the callback logic is that you can return a callback function which is executed when the callback actor will be stopped. This is where you can run code to clean up your side effects. Think about it as the function you return from a use effect if you are a React developer. So there I will loop over the default events again, but instead of add event listener, I will call remove event listener. This is not necessary. Okay. And the other thing we want to do is to listen to documents, add events listener, visibility change, and here we can't directly use a handle window event because we need to run some different logic to know if the document hidden property is true or false. So I'll create function handle document visibility change, and so this function takes no parameter, and if document hidden equals false, then we execute the handle window event function. Okay, let's do this. And we need to clear this event too at the end of the callback. Remove event listener. Okay. Great. So now that we have this DOM listener logic, we need to use it in the machine. To do so, I will create this actors object here, listen DOM events, which is this DOM listener logic. Here I'm renaming the logic to use my convention for actions and actors name. I like to use this sentence case, so I do it here too. And this actor needs to live for all the state machine live. So this is what we call a root invocation. We will invoke this at the root. So here invoke src listen DOM events. Great. So when the state machine is executed, when you start a machine with the use actor hook, for instance, this is creating this actor, and every time the actor sends with the sendback function the activity event, then the state machine receives it. So we have nothing more to do to make this work. Now we can test if it works in the browser. Now that we scaffolded the machine, we need to wire it to the browser and the React code. This is the playground we will use, and in the browser we can see that we want to display whether the user is currently idle or not, and when the user was last active. So in the code, we need to use the use actor hook from XState React to get the snapshot and the send function. Use actor, and we need user. I think I didn't exported the machine from the file, so here export. Okay, go back to the demo. User activity machine. Great. Sincerely, we don't need this send function. We only need the snapshot because the user code won't be sending events to the machine. This is all handled by the DOM listener actor, so this is incorporated inside the machine. Snapshots, great. So here we can say the user is idle or not. We will display true or false. So snapshot matches inactive. The user is idle when the state matches inactive. Okay. And when the user was last active, we will be using the difference in second function from date functions. This is one library I really love, and I will use it now to compare with snapshot context last active. Now comes from this hook use timestamp defined below. This hook uses a set interval to get the current date every second so that the browser will refresh in this case. So don't interact with the page. You can see idle is false, and now it's true. If I interact with the browser, the timer is not incremented and idle remains false. There is one way we want to improve the state machine. If the user interacts a lot with the page, if the user moves the mouse a lot or resizes the window a lot, there will be a lot of event handlers being called, and this is not what we want. We want to restrict how much the callbacks and the timers will be executed and recreated. So what we want to do here is to throttle, as useIdle composable from VueUse does. We want to throttle the state machine. Let's go back to the state machine code. And here, instead of recreating the timer directly when we receive the activity event in the active state, we want to throttle. And if you have seen the other video I did about the throttling pattern, you would know that throttling is just stopping to listen to an event. So Here we create a new state, idle. The initial state is idle, and there, instead of directly going to active, we go to throttling. In the throttling state, we create a timer. After 50 milliseconds, we go back to idle state. We remove the render keyword. Here, throttling. Okay, and this target is misleading. This target can no longer work because the idle state and the inactive state are not siblings. There is one depth level of difference. So what I like to do is to rely on a final state to mark the state tone and then target to its sibling state. So here I create a done state, which is of type final. And with final states, you can use the on-done transition. This transition will be taken when the state active reaches one of its child state, which is marked as final. You can have several final states on the same compound state, and in this case I have a single one. So inactive, and there, instead of inactive, which is impossible, I go to done. Okay, it should be working. Let's see in the browser if it does. I stop interacting with the page, then I wait 5 seconds and I go to the idle state. Now if I interact with the page, you can see that the timer remains at 0 seconds. This is because the throttling works and we did a good job. We could stop here because we have a state machine that works. We implemented this user activity state machine that detects when the user is idle. But I want to take it a step further. The useIdle composable from the VueUse library is able to take parameters to change the behavior of the hook. For instance, it can take a dynamic events array to configure the events that are listed on the window global object. You can decide whether you want to listen for visibility change, and the timeout is dynamic too. So we want to update the state machine to be as dynamic as the useIdle composable. To make a state machine configurable that way with XState 5, we can rely on the new input property. Previously, with XState 4, we had to create a state machine creator function. We would have created a create user activity function, and this function would have returned a new state machine based on the input received by the function. So we would have taken events property, etc., and this would have modeled the state machine returned by the function. This is no longer needed with XState 5 because a new input property that does the same thing has been released. Let's see how we can use it. So I am back to the state machine and I will create a new type there. It will be input. Input will take, we will take the timeouts, which is optional. We'll take a list of events, and the type of this is window event name, which is an optional array, and listen for visibility change, which is optional too, and we'll make it a boolean. Let's keep things simple. The issue with the inputs is that it's only available for a subset of parts in your state machine. When you create the state machine, when you instantiate it, the input is available directly on the context. So here you can receive the input. But for the next actions, like here, you don't have access to the input. You only have access to the context. What we need to do there is to pass the input to the context. The input can be used to fill the default values for the context. This is what we will do. So I copy this into the context property and things just become non-optional. Okay, and now when we create the initial context, we want to set the timeout to be input.timeout and give it a default value of, we will say 1 minute. Do the same thing for the events. Input events defaulting to the default events array defined at the top of the file there. And please note that we will have to refactor this. We don't want anymore to use the default events by default. We will need to pass an input to the callback function too. This is possible, and we will see how. Let's define the rest of the properties. Listen for visibility change. Okay, and defaulting to true. Now, the first thing we will refactor is how we define the timeout delay. For now, I hard-coded this 5 seconds delay. We want to replace it with the timeout property received as the input. To do this, instead of using this hard-coded value, I will rely on a named delay. Let's call it activity timeout. And there, below the actors, I can define this dynamic delay. It will rely on the context and specifically the timeout value. The next step is to make DOM listener logic take an input as well. To do this, we can define some generics on the from callback function. The first generic is event object. I will just give it an any type, and the next one is tinput. So here we can define the events. The type is window event name as an array, and listen for visibility change, which is a boolean. Great. The function can take the input now, and instead of the default events there, I use input.events. The next step is for this listen for visibility change. We want to conditionally run this code. We want to conditionally apply the listener for the visibility change event on the document. To do this, input.listen for visibility change equals true. Then we do this, overrise, yes, oops, okay, so if listen for visibility change equals true, then we set the event listener and we remove the listener in the return callback. Great. Now that we define the callback needs to take input, we need to provide it when we use the actor. So here it's red because it says type src listen DOM events is not assignable to type undefined. The solution is to define input property, which is not optional, contrary to the overruns, and we will make it a function which takes the context and returns an object with context events and something So this is how you provide input to an actor that expects an input. Now that the state machine is okay, we need to provide the inputs to the user activity machine when we execute it with the useActor hook. So let's pass an object and define the input object to be. I will let events and listen for visibility change empty. I want to default to the default values, but I want the timeout to be of 5 seconds. The behavior should remain the same between this new version and the old one. If we test in the browser, I touch nothing. After 5 seconds we become idle, and then every time I interact, the state machine recreates the timer and we always remain to 0 seconds. Let's just try another timeout. Let's use 10 seconds. Let's reload. I do nothing for 10 seconds. And yes, we become idle after 10 seconds. We are all good, the state machine works perfectly. Let's just visualize it, because coding with XState is great, but Stately develops excellent tools to visualize state machines. And I love this visualization tool that allows you to inspect the state machine that runs in your browser. For every example on XState by example, you can visualize them by clicking on this visualizing button. So when I interact with the state machine, you can see that I remain in the active state. Because the 50 milliseconds timer is really short, you can see there is a bit of flickering between the states, but the most important is to see that it goes to the throttling state, then it goes back to idle, and if I stop interacting, the on-down transition is taken and we go to the inactive state. Thanks for watching this video. I hope you liked it. You can find the user activity example on XState by example. The code is on GitHub and you can find the links below. Thanks to the VueUse team for creating the useIdle composable, and see you for our next video. Bye.